Hello friends, I, Dhairya Bhatia, welcome you to my YouTube channel Maths DNA from Origin to Infinity. In this video, we are going to solve 4 more questions of CSIR-NET JRF November 2020. The question will be of part B. Before that, I have already uploaded a video on 6 questions of part B itself. You can watch it in the description link below. And yes, if you are preparing for GATE 2021 mathematics, then here is a gift for you. Get 1000 plus solved questions and revision material, a demo in the link given below in the description. Now let us begin. The seventh question is, given f and g are continuous functions on the closed interval 0, 1 such that f of 0 equals to f of 1 equals to 0 and g of 0 equals to g of 1 equals to 1 and f of 1 by 2 is greater than g of 1 by 2, then which of the following statements is true? The options are A. There is no t belongs to closed interval 0, 1 such that ft equals to gt. Second, there is exactly one t belongs to closed interval 0, 1 such that ft equals to gt. Option C says there are at least two t belong to closed interval 0, 1 such that f of t equals to g of t. Option D says there are always infinitely many t belongs to closed interval 0, 1 such that f of t equals to g of t. Now this question was so simple, and if you even have not prepared, you could easily solve if you are just good with drawing functions on a x and y axis, that is graphically representation of a function. Let me show you how. It is given to us that the function f and g are continuous and the values of f at 0 and 1 is 0 and of g at 0 and 1 is 1, as well as f of 1 by 2 is greater than g of 1 by 2. So let us draw these two functions. Here you can see that I have plotted fx as a continuous function as well as gx. Now fx is first increasing and then decreasing, whereas gx is first decreasing and then increasing. Both the functions are continuous and satisfies the given condition on x and y axis. So here you can clearly see that at 2 points these functions are intersecting, which means that fx and gx have at least 2t belongs to closed interval 0, 1 such that f of t equals to g of t, and this gives us our answer, that is option C. Moving on to the next question, let gamma be the positively oriented circle in the complex plane given by z belongs to C such that mod of z minus 1 equals to 1. Then 1 upon 2 pi I integral gamma dz upon z cube minus 1 equals to, and the options are A 3, B 1 by 3, C 2 and D 1 by 2. Now this question was also simple. If you just know about Cauchy integral formula, you could easily have solved it. Let me show you how. Firstly, it is given to us that a complex plane is mod z minus 1 equals to 1. And we have to find the value of 1 upon 2 pi I integral gamma dz upon z cube minus 1. Now here we have fz equals to 1 upon z cube minus 1, and we firstly find the singularity, that is denominator is been solved, that is z cube minus 1 equals to z minus 1 into z square plus z plus 1. We do this to check at which point is the function not defined. Now here we can see that only singularity, that is inside the given complex plane, is z equals to 1, because at z equals to 1 the denominator becomes 0 and the function is not defined. So we have singularity that is inside the complex plane, that is 1. So integral over gamma dz upon z cube minus 1 equals to 2 pi I into residue at z equals to 1, which will give us integral dz upon z cube minus 1 equals to 2 pi I into limit z tends to 1 z minus 1 into 1 upon z minus 1 into z square plus z plus 1. Here z minus 1 gets cancelled out and we get it as 2 pi I into 1 by 3. But remember, we have to find 1 upon 2 pi I integral dz upon z cube minus 1. That will give you the value as 1 upon 3, and hence the correct answer is option B. Moving on to the ninth question, that is a similar one as we solved ahead. Let gamma be the positively oriented circle in the complex plane given by z belongs to C such that z minus 1 equals to 1 by 2. Then line integral gamma z into e raised to 1 by z upon z square minus 1 dz is, and the options are A I pi e, B minus I pi e, C pi e, and D minus pi e. Here also we apply the same formula. Firstly, the complex plane that is given to us is mod z minus 1 equals to 1 by 2, and we have to find the integral z into e raised to 1 by z upon z square minus 1 dz. Then here the fz that is we have equals to z into e raised to 1 by z upon z square minus 1. Again, we first simplify the denominator. That will give us z square minus 1 equals to z minus 1 and z plus 1, which means that there are two singularities, one at 1, another at minus 1. Now we check that which of the given point is inside the complex plane and which is outside the complex plane. Because if it is outside, we do not need to solve it. We just need to check and find the residue at the point that is inside the complex plane. Now at z equals to 1, we have mod of 1 minus 1, that will be equals to 0, and that is definitely less than 1 by 2. So it is inside the plane, that is inside the given portion, and at z equals to minus 1, it will be 2, which is greater than 1 by 2, and that is outside the plane. So the integral of z into e raised to 1 by z upon z square minus 1 dz will be equals to 2 pi I into same residue at z equals to 1, because that is the point that is inside the plane. That will give you 2 pi I into limit z tends to 1 z minus 1 into z into e raised to 1 by z upon z minus 1 into z plus 1. Simplifying it, we get 2 pi I into e by 2, that is nothing but I by e, and that is the answer, option A. Moving on to the 10th question. Now this question seems to be a bit lengthy one, but the solution is the shortest. First, let us read the question and understand it properly. In an examination involving multiple choice questions, a student works out the solutions of 50% of the questions. In the remaining questions, the student guesses the answer. However, when the answer is guessed, the probability that it is correct is 0.3. When the student works out the solution, it may be wrong with probability 0.10. If the answer to a particular question is correct, what is the probability that the student guesses the answer? And the options are A 0.25, B 0.50, C 0.90, and D 0.30. Now think that the paper had total 100 questions and then simplify it. Now let the total number of questions are 100. Then student solves 50%, that is a student is solving 50 questions. Here we are not saying whether it is correct or incorrect. We are just saying that he or she is solving 50 questions. Then the remaining questions, that is remaining 50 questions, he is guessing the answer, that whether it may be A, B, C or D, whatever. It is also given that when the answer is guessed, the probability that it is correct is 0.3, which means that out of 50 questions, there is 30% chance that the answer is correct, which means that 15 answers are correct out of that 50 questions. And also it is given that when solved, 0.10 is the probability it will be wrong. But remember, we have to find the correct one, which means that 90% is the chances that the when student has solved the question, the answer is correct, which means that out of 50 which he has solved or she has solved, 45 answers are correct. This gives us total correct answer, that is 60, 15 that are guessed and 45 that are solved. Now we have to find the probability that if the answer is correct, then what is the probability that the student has guessed the answer, which means that the total correct answers are 60, and out of which 15 were the questions or 15 were the answer where he guessed the answer, and that gives you 0.25, and hence the correct answer is option B. Thank you, and you can be a member of our social club and watch out more than 190 plus videos on our YouTube channel and get a complete study material on our Telegram channel.